the meaning of the term acceleration here would be the change in velocity. This is, of course, the scientific meaning of the word acceleration. In layman's term, whenever you're just talking with a friend, when you say you are accelerating, that means you are speeding up. Okay, but in science, acceleration is just not speeding up. It means more than that. Okay, so acceleration in science here, this means the change in velocity. Now remember, we said velocity is speed with direction. Okay, so that means acceleration is the change in speed with direction. Okay, because of course acceleration is the change in velocity. Now, the next slide here asks you a very important question. It says, when can acceleration or change in velocity happen? These are the three important conditions through which acceleration may happen. There's speeding up, there's slowing down, you'd call that deceleration, and of course, there is a change in direction. We have the formula for acceleration here. Okay, formula for acceleration, that would be Vf minus Vi over t. Now, in this formula, A, of course, would be acceleration. Vf, that's your final velocity. Vi, that's your initial velocity. And of course, t is time. Okay, so again, this is going to be the formula for acceleration that we are going to use whenever we solve the problems later. Now, the unit for acceleration that we have would be meter per second, because remember your formula for, or the unit for velocity would be meter per second. And since you have time here, which also is using the unit of s or second, your unit for acceleration would be meter per second, or you can simply just use meter per second squared. For the next slide here, these are some of the important terms that I'd like you to know. Whenever you say final velocity, that's the last velocity of the object. Initial velocity, of course, when you say initial, that's the starting velocity, or that's the first velocity that the object has. When you see the term started from rest, okay, if an object starts from rest, that means initial velocity is 0. That means it was not moving at first, okay? Initial velocity is 0. Now, if you see the terms came to a stop, that means final velocity is 0. Okay, so these are some of the terms that you are going to find in the problems that you are going to solve later. Take a look at your sample problem here. Okay, you have a ball that slows down from a velocity of 30.6 meter per second to 11 meter per second during a 2.75 second period. What is its acceleration? So in our calculations here, again, final velocity is 11 meter per second. And initial velocity is 30 meter per second, 30.6 meter per second. So that means you need to analyze the problem whenever you read it. Okay, does not mean that the first, whenever you see a first quantity there, that does not mean that that should be your initial velocity. Okay, you need to read the problems carefully. Okay, so again, your final velocity is 11 meter per second. Initial velocity is 30.6 meter per second. Then, of course, you are given your time to be 2.75 seconds. Now, using your formula, again, we start with final velocity, that's 11 meter per second, and we subtract from that your initial velocity of 30.6 meter per second, that whatever is the difference here, we would divide that by the time, which is 2.75 seconds. Okay, now continue with our calculation. Your 11 minus 30.6, that would give us negative 19.6 meter per second. Okay, so that's negative 19.6 meter per second, and of course that would be divided by 2.75. And so your final answer would be negative 7.13 meter per second, or that would be just equal to negative 7.13 meter per second squared. Now we see that this is negative. That means your ball is actually slowing down. Okay, the ball is slowing down. It is decelerating.